And then, okay, to digress. This is everything we just learned, but now we're going to put it on. Alright, so real quick, slopes, negative, positive, no slope, zero slope. Okay, we've got an equation here of x squared minus 2x plus 3. I want to make sure this thing is actually recording. Okay, it is. So, and that's this kind of, and it's not this per se, you know, it's just, it's something that looks like this. I'm just saying that a quadratic looks like this. And let's just pretend, so it's not, we're not looking at this exactly, we're just looking at one that's quadratic. And so, what I did was I had it come down. We noticed that it's got a slope here and a negative 4 slope and a positive 4 slope, because we know that about parabolas. They're symmetrical. And then down here at its base, at its minimum, it's going to have a 0 slope. And those slopes are the change in the function. And the change in the function is what we're looking for when we're looking for a derivative. So the key factors of finding a derivative is finding the change in your function. Okay? So we used our old slope method of y sub 1 minus y sub 2 over x sub 1 minus x sub 2, or the flip it and smack it method. So we flip the coordinates and smack them, and then they work out. Or we look at it now in our new way of looking at it. A derivative is really the change in y over the change in x. Okay? So you could take 2 points on a function, draw a line through it, find the slope, do the same on the other side, draw a line through it, find the slope, and you're finding a change in the function at that point, right? And then this point, it's a little harder, but what you're trying to do is find what the slope is here. Well, here it's a straight line, so we know that that slope is 0. So we're trying to find purposeful points, like a point over here and a point over here, kind of seeing what's happening. And then from that, we graph the change in the function. And the change in the function is, it goes from a negative at, say, negative 1, where x is negative 1. It goes from a negative 4 slope, so that's why we graphed a negative 4, negative 1, to 0 at 0, and then at 4, at negative 1, there's another 4 slope here, 4 over 1, the 4 over the 1, so we got a slope of 4. So this is positive, this is negative, this is a negative 4, this is a positive 4 for the x, and the y value in this case is the that is the y value, sorry, and the x value in this case is just the given, kind of on, we're kind of comparing it to this equation up here, this function. So they're going to be these points right here, so negative 1 and 1. And so once you plot those points, you can draw your line, and you find that the line also goes through the 0 point, and it's giving us a kind of an estimation of what's going on here. Okay? Now, if we take a look, what we wanted to do next was we wanted to look at what functions do over a course, over time. So, I want to remind you of what functions do. So, if you remember back to 99 and 102, we talked, and 103, we talked about how functions, how they occur. So, like with the linear function, with a single variable, right? or not a single variable, with a first degree function, something to the first degree, you deal with, so y equals x, so you deal with a line of some sort, right? With y equals x squared, you're dealing with a parabola of some sort. Now it could look like this, or it may look like this, and that would be a y equals a negative x squared. Okay? And then we take it a step further and we go, okay, what about x cubed? And then we found something that was different with x cubed. With x cubed, we thought, hey, x squares, they're positive, they smile in the beginning. And, oh, they're negative, they frown. But what we found with x cubes when we graphed them on the calculator, we found that they didn't smile in the beginning. They frowned in the beginning and they smiled at the end. And the opposite happened with the negative x cubed. They smiled in the beginning but frowned in the end. And then we're like, well, what's going on with this? Is there a pattern? And so then we did y equals x to the fourth. And we found, wait, what? This is frustrating. It smiles in the beginning and frowns in the end. And this one, minus x to the fourth, well, it frowns in the beginning and smiles in the end. And we're like, whoa, what's going on here? All right, well, let's look at the next one. Let's see what happens there. So we went to y equals x to the fifth. And we found that, again, it frowns in the beginning, but smiles in the end. And now we see the pattern. Y to the negative fifth, negative x to the fifth, it smiles in the beginning, but frowns in the end. Okay, and so we noticed a couple of things, right? Oh, and by the way, y to the negative x went down. Y to the positive x went up. So positive slope, negative slope. Okay? So we started figuring some stuff out. One thing we figured out is if it's got one exponent, it's got no curve to the function. If it's got two exponents, or a power of 2, or a degree of 2, it's got one curve, a possible one curve. Sorry. If it's got a degree of 3, the most it can have is 2. If it's got a degree of 4, the most it can have is 3. If it's got a degree of 5, the most it can have is 4. And so on and so on and so on. So this is crucial to the understanding of creating a derivative graph. So when we look at a new graph,